Hello, my name is Beth Dixon, and I am the Math Lab Coordinator and work in MBSS 222. And it is my job to help you through your math courses here at Walter State. So as part of that, I record these lessons, and this one is on factoring trinomials. It is part 3A, and there's a 3B of factoring on trinomials. And trinomials are probably one of the most common factoring that we do. And that's one reason why I've kind of divided it up. And actually, part 4 is also on factoring trinomials. So as you can see, it's one of the most important things that we do in factoring, or at least the most common. And as we start this, in this factoring lesson, there are lots of different ways that your teachers will be explaining factoring to you. And so as I start this lesson, I'm assuming that you've been taught factoring by grouping. And so if you've not done factoring by grouping, you need to go back and watch the part 2 lesson on factoring by grouping that I've done so that you can kind of follow along with the approach that I'm doing. If your teacher's not doing factoring by grouping, you may want to go on and listen to some the part 4 of my lesson, which will be a little bit not doing the factoring by grouping, but using more trial and error. As I do this, let's look at this first example here. And as we're looking at this, we've got 2x squared plus 10x plus 3x plus 15. And if we were factoring this using factoring by grouping, we would look at the first two terms and factor out the common factor, which would be 2x, and then we would be left with x plus 5, with the 2 going into the 10 5 times, and then the 3x plus 15 shares a common factor of 3, and we'd be left with 3 goes into x, 3x, x times, 3 goes into 15 5 times, and then we'd be left with the x plus 5 as our common factor, and then the 2x plus 3 in the front, and we would be finished factoring it. But notice something about this problem. Notice that these are like terms. And generally, we wouldn't be given this problem in this form. Generally, we add like terms. So generally, that would have been given as 13x. Well, how are we going to get from the 13x to the 10x plus 3x that works to give us our factoring? Well, let's look at that 10x and that 3x. And we have a 15 there. Oh, and we've got this 2x squared there. What do we notice about those numbers? And I hope you see a pattern here, and I hope it just kind of jumps off. When I wrote these two numbers down, I hope you see it. And if you don't, then I hope after I show it to you that you see it. Okay? That 10x and that 3x and that 2x squared and that 15x squared share something. If I multiply 10x times 3x, guess what I get? I get 30x squared. If I multiply that 2x squared times 15, guess what I get? I get 30x squared. And that's going to hold true every time I multiply and every problem that I do on these trinomials. That if I break this up correctly, that when I multiply these two numbers, it'll be the same as if I multiplied those two numbers. So my first step will always be to multiply this number and this number so that I can get a certain pairs so that I can figure out what that middle term is. And you're going to say, what did she just say? Don't worry, we're going to go back over it very slowly to get those answers. But let's look and do this second one to show how that's working. Okay? Now, if that works, then 3x squared plus 4, or excuse me, 3x squared times 4, so that's 3x squared times 4 gives me 12x squared. And 2x times 6x should also give me, well, lo and behold, it does, 12x. Well, let's watch and see if this factors. Common to the first two terms is an x, and we're left with 3x plus 2. And again, I'm assuming that you know how to factor by grouping. If not, you do need to watch that video or that podcast. And common to the last two terms, 6x and the 4, well, common to that would be a 2, and 2 goes into 6 3 times, 2 goes into 4 2 times, and that gives me that 3x plus 2 that's common. And in front of that, x plus 2. And lo and behold, it works. And again, notice that the multiplication on the outside gives me the same as the multiplication of the two numbers on the inside. And because that holds true every time, that's the pattern we're going to follow to change our middle terms. Because again, they're not going to be given to us in this broken out form so that we have the four terms. They're going to be given like this next one, which is 2x squared plus 11x plus 5. Our like terms are going to be added together. And we want to rewrite this so that it's an expression or a factored form of two binomials multiplied. So how are we going to change this back into its multiplied form, into its factored form? Well, first we want to see what those outside terms multiply to. That's your first step. Okay? And so 2x squared times 5 is 10x squared. Well, with 10x squared, that means we have some choices of what we could have for our middle term. Our choices could be 1 times 10x, or excuse me, 1x times 10x, 2x times 5x, and really that's it, because those are the only whole numbers or whole numbers that multiply to give me 10. Now, there's some rules for these signs that we're going to kind of be introducing as we go along, but notice in this case that we want it to be a positive 10, and we need it to be a positive 11 here. So to make sure that we add to be 11, well, I can't add 2 and 5 and get 11, so that's not going to be it. It's got to be 1 and 10. And to get a positive 11, they both need to be positive numbers. Positive 1 plus a positive 10 gives me a positive 11. Now, the only way that I can rewrite this is if I do not change the value of the expression. And I'm not changing the value of 11x if I change 11x into 1x plus 10x. I'm just rewriting it, expressing the 11x differently. So now I have 2x squared plus 1x plus 10x plus 5. And so all I've done is rewrite it, changing that middle term into something that makes our pattern hold true, which is the first and the last term multiply to give me 10x squared, and the middle terms multiply to give me 10x squared. So let's see if it factors. What's common to the first two terms is just an x. 2x plus 1. Factor out that common factor of an x. The last two terms have a common factor of a 5. 2x plus 1. So that 2x plus 1 is the common factor. And I'm left with x plus 5. And just to be sure, let's take the 2x plus 1 and the x plus 5 And let's use our FOIL to check it. 2x times x is 2x squared. 2x times 5 is 10x plus 1x. 1 times 5 is 5. So we have 2x squared plus 11x plus 5. So when we multiply it back, we get what we started with. So there's my answer. Okay, let's look at another example. Okay, we're going to multiply the first and last terms. 2x squared plus 5 again. And I did this on purpose to start out with because we're going to stick with the 10x squared. Now notice I'm keeping the x squared there with it, but now I'm going to drop it because we just know it's going to be 1 and 10 or 2 and 5. And in this case, it's going to be the 2 and 5 because this time we need a 7. Now this time, notice we need it to be a negative in the center. To get that negative in the center, we need both of these to be a negative. 2x squared minus 2x minus 5x plus 5. Now notice that 2x squared plus 10x squared is a positive 10x squared. So that means I need to multiply to be a positive. Well, is a negative 2x times a negative 5x equal to a positive 10x squared? It sure is. And that brings us to one of our rules for factoring. Okay? If that last term is positive, which is right here, that last term is positive, then the signs of the factors will both have the same sign as the middle term. We'll come back to that in just a minute. But when using factoring by grouping, the replacement terms, which is what we're going to replace here in just a moment, will both have the same sign as the original middle term. So notice that we have a negative there. Notice when we replace them, both of our replacements have the same sign as the middle. Okay, and notice in our previous example, both of the signs were the same as the middle. They were both positive when this last term is positive. So when this last term is positive, both signs match the middle term. Both signs here match the middle term. Now we're going to factor. What's common here would be a 2x, x minus 1. What's common there? Remember, we always bring down that sign. Common 5. Negative 5 goes into negative 5x, leaves me a positive x. Negative into a positive, divide, leaves me a negative. 5 goes into 5 one time. That gives me the common factor of x minus 1 times 2x minus 5. Now in this case, notice the last term is negative. So this will work a little bit different because when we multiply the first and last term, we get a negative 36x squared. So now we're dealing with something that's not a 10 here. Okay, I gave you a new number here. And in this case, what are we going to get? Well, the possibilities are a little bit longer. We get 1 in 36. 2 times 18, 3 times 12, 4 times 9, and 6 times 6. Now remember, in this case, we've got to multiply to get a negative. To multiply to get a negative answer, one of these has to be positive and the other one has to be negative. So that means instead of adding these terms to get 16, we're going to subtract these terms to get 16. So when that last term's negative, we think subtract. Well, 6 minus 6 gives me 0. 9 minus 4 gives me 5. 12 minus 3 gives me, excuse me, 9. 18 minus 2 gives me 16. So I need a positive 16. Well, what does that mean? That means I need a negative 2x and a positive 18x. That expression will exchange for a positive 16x. But when I multiply negative 2 times 18x, I will get that negative 36x squared. So it meets both sets of rules. Now, how am I going to get that? Well, with 36, there's an extreme long list. So one of the things you're going to do is you can use your calculator. And you're going to go to y equals, clear out any old equations that you have, and type in the number that you have, which I'm going to type in that negative 36. Then you're going to hit your divide and your x. And I didn't show you the keys for that, but you hit divide and then x because I want you to see the screen. And then second, and then you're going to hit the table, which is above your graph key. Mine was set on something else that yours shouldn't be set on, so we'll just change it. Okay, now notice at 0 you get an error. That's okay because it's never going to be 0 as one of your factors. Well, there's 1 and negative 36. Well, a positive 1 and a negative 36 does not give us 16. A negative 18 and a positive 2 gives us a negative 16, so that's not going to work. Negative 12 and a positive 3, that doesn't work. Gives us 9. Negative 5. Oh, that's a fraction. We get to skip it. That gives us 0. That's a fraction. We get to skip it. Get to skip the fractions. Well, there's a positive 9 and a negative 4. That gives us a positive 5, but it's not what we're looking for. A fraction, a fraction, there's another whole number. But it gives us 9. We're not looking for it. Fraction, 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 fraction. Oh, there's another whole number. 18 minus 2 gives us 16. And there's the pair we're looking for. So we can just use the calculator to create this list of numbers and go scroll down until we find the pair that we're looking for. It's a great help to find the correct pair. Then once you find the pair, 3x squared minus 2x plus 18x minus 12. Now another hint for when you put your terms in, I particularly prefer to have a plus here and my minus here because it makes that factoring easier. Remember that it's always harder to factor with that negative there because it always flips and changes this sign when we're doing our factoring by grouping. If both of them are negative, we have no option. But if only one of them is negative, it's always going to be easier to put the plus sign here. So I'm always going to put the negative first and the positive second. But it doesn't really matter because it'll work out in the long run either way that we do it. Common to the first two terms is just the x, then 3x minus 2. Common to the second two terms is a 6. And again, because we bring that sign down, it's always easier to bring the plus sign down if we have an option Then we get 3x minus 2, a common factor of 3x minus 2 times x plus 6. And I'm going to stop here because this is a good place to stop to keep the lessons from being too long. But there is a couple more examples that I want to do on this. So please watch Factoring Trinomials by Grouping, which would 3b, which is just really a continuation and a couple of more examples on this same type of problem. Thank you.